Introduction to Risk-Based Inspection, RBI, Purpose of a Risk-Based Inspection Program, Core Elements of an RBI Program, Risk Assessment Methodology in RBI, Flexibility in Application of RBI, Consistency and Quality in RBI Implementation, Mechanical Integrity Focus of RBI, Integration of RBI with other reliability programs. Target audience for RBI programs, Benefits of Risk-Based Inspection, Limitations of Risk-Based Inspection, Continuous Improvement and Reassessment in RBI, Conclusion and Key Takeaways. Risk-Based Inspection, RBI, is a structured, systematic methodology used to prioritize inspection activities based on the risk posed by potential equipment failures. As defined in API recommended practices such as API RP 580 and API RP 581, RBI integrates both the probability of failure, POF, and the consequence of failure, COF, to determine risk levels for pressure equipment, piping, and associated assets. The primary objective of RBI is to ensure that inspection resources are allocated where they provide the greatest reduction in risk, thereby improving safety, reliability, and cost-effectiveness. Unlike traditional time-based inspection approaches, RBI focuses on understanding damage mechanisms, degradation rates, and operating conditions that influence equipment integrity over its lifecycle. This risk-informed approach supports informed decision-making by engineers, inspectors, and asset managers. RBI does not eliminate the need for inspections, rather, it enhances inspection planning by tailoring inspection methods, intervals, and coverage based on risk. The scope of RBI extends across design, operation, inspection, and maintenance phases, making it a key component of modern mechanical integrity and asset management systems. API RP 580 emphasizes that RBI is a living process requiring periodic reassessment as conditions, data quality, and operating parameters change. By embedding RBI into an organization's integrity management framework, companies can proactively manage risk, prevent failures, and comply with regulatory and industry best practices. The purpose of a risk-based inspection, RBI, program, as outlined in API Recommended Practice 580, is to provide a rational and defensible basis for managing inspection activities in a way that reduces risk to acceptable levels. The program aims to protect personnel, the environment, and assets by identifying and understanding the key risk drivers associated with equipment failure. A fundamental objective of RBI is to optimize inspection efforts by focusing on equipment with the highest risk, rather than applying uniform inspection intervals across all assets. This enables organizations to achieve higher levels of safety and reliability while controlling inspection and maintenance costs. RBI also supports regulatory compliance by demonstrating that inspection decisions are based on sound engineering principles and documented risk assessments. Another important purpose is to improve knowledge of damage mechanisms and degradation processes, allowing engineers to select appropriate inspection techniques and mitigation strategies. RBI programs also facilitate long-term planning by aligning inspection strategies with business objectives, such as extending equipment life, improving availability, and minimizing unplanned shutdowns. Furthermore, RBI promotes continuous improvement by requiring periodic reassessment of risk as new data becomes available or operating conditions change. In essence, the purpose of RBI is not only to prevent failures, but also to provide a structured decision-making framework that balances safety, reliability, and economic considerations throughout the asset lifecycle. An effective risk-based inspection program is built upon several core elements that ensure consistency, technical rigor, and repeatability. According to API RP 580, these elements include data collection and validation, identification of damage mechanisms, assessment of probability and consequence of failure, risk evaluation, inspection planning, and documentation. High-quality input data is critical, as the accuracy of an RBI assessment depends heavily on equipment design details, operating conditions, inspection history, and materials of construction. Damage mechanism review is another essential element, requiring subject matter expertise to identify credible degradation modes such as corrosion, fatigue, creep, or environmentally assisted cracking. The probability of failure assessment evaluates the likelihood of these mechanisms leading to loss of containment, while the consequence assessment examines potential impacts on safety, environment, and business. Risk is then evaluated by combining POF and COF, often using qualitative, semi-quantitative, or quantitative methods. Based on the evaluated risk, inspection plans are developed, specifying inspection intervals, techniques, and coverage. Finally, proper documentation and management of change ensure transparency, traceability, and continual improvement of the RBI program. Together, these elements form a comprehensive framework that supports risk-informed inspection decision-making. Risk assessment is the technical foundation of a risk-based inspection program and involves systematic evaluation of both probability and consequence of failure. API RP 580 allows flexibility in the selection of risk assessment methodologies, ranging from qualitative approaches based on expert judgment to fully quantitative methods using probabilistic models, as detailed in API RP 581. The probability of failure assessment considers factors such as damage mechanisms, corrosion rates, inspection effectiveness, and operating history. Consequence of failure assessment evaluates potential outcomes including personnel injury, environmental impact, asset damage, and production loss. These consequences may be expressed qualitatively or quantified in terms of financial impact or risk to life. The selected methodology should be appropriate for the complexity of the equipment, availability of data, and organizational objectives. Importantly, AP emphasizes that the chosen method must be applied consistently and documented clearly. Risk assessment results are typically presented in risk matrices or risk plots, which help visualize relative risk levels and support prioritization. This structured assessment enables organizations to focus resources on the most critical equipment and provides a defensible basis for inspection and mitigation decisions. One of the defining characteristics of API Recommended Practice 580 is its emphasis on flexibility in the application of risk-based inspection. The standard is designed as a framework rather than a prescriptive set of rules, allowing organizations to tailor RBI implementation to their specific industry, asset types, and risk tolerance. RBI can be applied across a wide range of facilities, including refineries, petrochemical plants, chemical processing units, and upstream or downstream installations. Flexibility also extends to the level of detail in the assessment, enabling companies to apply screening-level qualitative RBI for large populations of equipment, while reserving detailed quantitative analysis for high-risk or complex assets. API recognizes that organizations differ in data availability, expertise, and regulatory environments, and therefore encourages adaptation while maintaining technical rigor. This flexibility supports phased implementation, where RBI programs can mature over time as data quality and organizational competency improve. By allowing different methodologies and levels of sophistication, API RP 580 ensures that RBI remains practical, scalable, and aligned with business needs without compromising safety or integrity objectives. While flexibility is encouraged, API RP 580 places strong emphasis on consistency and quality in the implementation of risk-based inspection. Consistency ensures that similar equipment under similar conditions is evaluated using the same assumptions, criteria, and methodologies. This is critical for maintaining credibility and comparability of risk results across a facility or organization. Quality in RBI implementation is achieved through defined procedures, qualified personnel, peer reviews, and robust documentation. API highlights the importance of competency, stating that RBI assessments should be performed by multidisciplinary teams with appropriate engineering, inspection, and process knowledge. Quality assurance measures, such as validation of input data and review of assessment results, help prevent errors and bias. Consistent application of RBI also supports regulatory compliance and facilitates communication with stakeholders. By maintaining high standards of quality and consistency, organizations can rely on RBI results to make critical inspection and maintenance decisions with confidence. Mechanical integrity is a central focus of risk-based inspection programs as defined in API recommended practices. RBI is specifically designed to support the integrity management of pressure vessels, piping systems, storage tanks, and related equipment that are susceptible to degradation over time. By identifying credible damage mechanisms and assessing their progression, RBI helps ensure that equipment continues to perform its intended function safely and reliably. The methodology supports proactive identification of integrity threats before they result in failures or loss of containment. RBI also aligns closely with mechanical integrity requirements in process safety management systems, providing a risk-informed basis for inspection, testing, and maintenance activities. Through targeted inspections and mitigation strategies, RBI contributes to extending equipment life, reducing unplanned outages, and preventing catastrophic failures. This strong focus on mechanical integrity makes RBI an essential tool for asset integrity engineers and inspection professionals. API RP 580 emphasizes that risk-based inspection should not be implemented in isolation, but rather integrated with other reliability and risk management programs. RBI complements process hazard analysis, PHA, reliability-centered maintenance, RCM, and asset integrity management systems by providing detailed insight into equipment-specific risks. Information from RBI assessments can be used to support maintenance strategies, operational controls, and mitigation planning. Conversely, data from operations, maintenance, and incident investigations can enhance the accuracy of RBI assessments. Integration ensures that risk is managed holistically across the organization, avoiding duplication of effort and conflicting priorities. By aligning RBI with broader reliability initiatives, organizations can achieve more effective risk reduction and improved overall asset performance. The target audience for a risk-based inspection program includes a wide range of technical and managerial stakeholders. Primary users include inspection engineers, corrosion specialists, mechanical engineers, and asset integrity professionals responsible for developing and executing inspection plans. Operations and maintenance personnel also play a critical role by providing operating data, identifying abnormal conditions, and implementing mitigation actions. Management stakeholders rely on RBI outputs to support strategic decision-making related to risk tolerance, capital planning, and resource allocation. Regulators and third-party auditors may also review RBI programs to verify compliance with industry standards. API RP 580 underscores the importance of effective communication of RBI results to all relevant audiences to ensure alignment and understanding of risk-based decisions. Risk-based inspection offers numerous benefits when implemented effectively in accordance with API recommended practices. One of the primary benefits is improved safety through focused attention on high-risk equipment and failure scenarios. RBI also enhances reliability by reducing the likelihood of unexpected failures and unplanned shutdowns. From an economic perspective, RBI enables optimization of inspection and maintenance costs by avoiding unnecessary inspections on low-risk equipment while ensuring adequate coverage of critical assets. The methodology improves understanding of damage mechanisms and risk drivers, supporting better engineering decisions. RBI also provides a structured and auditable basis for inspection planning, which is valuable for regulatory compliance and corporate governance. Over time, the use of RBI can lead to extended equipment life, improved asset availability, and more effective allocation of engineering resources. Despite its advantages, API RP 580 acknowledges that risk-based inspection has inherent limitations that must be understood and managed. RBI results are highly dependent on the quality and completeness of input data, and inaccurate or missing data can lead to misleading risk conclusions. The methodology also requires significant expertise and multidisciplinary knowledge, which may not be readily available in all organizations. RBI does not eliminate uncertainty, as damage mechanisms and failure behavior can be complex and variable. Additionally, RBI should not be viewed as a replacement for sound engineering judgment or regulatory requirements. APE emphasizes that RBI is a decision support tool, not a guarantee of failure prevention. Understanding these limitations is essential to ensure that RBI is applied appropriately and responsibly. Continuous improvement is a fundamental principle of risk-based inspection as described in API RP 580. RBI is not a one-time exercise, but a living process that requires periodic reassessment as new information becomes available. Changes in operating conditions, inspection findings, damage rates, or process fluids can significantly affect risk levels. API recommends updating RBI assessments following major changes, incidents, or at defined intervals to ensure that inspection plans remain valid and effective. This iterative process supports learning, improvement of data quality, and refinement of assumptions. By embedding continuous improvement into RBI programs, organizations can maintain alignment with actual operating risk and enhance long-term asset integrity. In conclusion, the scope and elements of a risk-based inspection program as defined in API Recommended Practice 580 provide a comprehensive framework for managing equipment integrity and risk. RBI integrates technical analysis, engineering judgment, and business considerations to prioritize inspection activities based on risk. Key elements such as purpose definition, flexibility in application, mechanical integrity focus, and understanding of benefits and limitations are essential for successful implementation. When applied consistently and integrated with other reliability programs, RBI enhances safety, reliability, and cost-effectiveness. Ultimately, RBI supports informed, defensible decision-making and represents a cornerstone of modern asset integrity management in engineering-intensive industries.